Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor from Civil Engineering Department. Today we are going to start. The next one is the hydraulic modification. In previous classes, we understand the various mechanical modifications. Coming to the hydraulic modifications, it's completely under liquid point of view, that too in water relevant. So these modifications which are relevant based on the water focused. So in these, what we understand is pore water is focused out of the soil. That means in terms of drains, various kinds of drains are there, and it depends upon some of the natural drains, some manufactured, human kind of drains, all are available. So in this, we are going to understand and we have to done the modification in hydraulic point of view for ground improvement point of view. So for the required project, how we are going to improve the hydraulic modifications for the client requirement. So in this, in coarse grained soils, this is achieved by lowering the groundwater level through pumping from boreholes or trenches. So whether boreholes or trenches in coarse grained soils, lowering the groundwater level through pumping. So whenever required height of the groundwater is required, it depends upon the conditions. So whenever we are going to reduce the groundwater level, so for example, groundwater level is like this, we are going to reduce the groundwater level till this, up to some extent. In that particular point of view, we are going to, in that too coarse grained soils, so pumping is the process from boreholes or trenches. Coming to the fine grained soils, it depends upon which type of soil condition there in the region, there where we require the modification. So that's also plays a major role. So coarse grained soils, we are pumping from boreholes or trenches. Coming to in fine grained soils, the long term application of external loads, that means preloading or electrical forces, electrokinetic stabilization is required. In fine grained soils, we are going to, based on the preloading conditions or electrical forces, so it is required for the fine grained soils in this, for fine grained soil hydraulic modifications. Coming to the hydraulic modification can be termed as also dewatering. Dewatering. So we are lowering the groundwater level, dewatering. So this is the word which we use for hydraulic modification. So in this, dewatering means modify ground by lowering the water table. This is called dewatering, or redirecting the seepage, or simply reducing its water content. It's a very simple word. Dewatering is nothing but we are going to reduce the water content in the required area. In most of the cases, we are applying for the foundations. So why? What is the purpose? Why dewatering is required for the condition? So to provide suitable working surface of the bottom of excavation. So it depends. Some of the ground conditions, in ground level, the water table level is near to the ground. In such cases, so whenever we are doing the excavations, the water is coming to the outside. So in that particular purpose, one of the purpose for dewatering. So to provide the suitable working surface of the bottom excavation. So lowering the water table can also be utilized to increase the effective weight of the soil. And one more important thing is whenever the water table is near to and whenever we are doing the construction works for foundations or some other drainage works, irrigation purposes, dams, some other, what are the different structures whenever we are constructing, in that particular, the soil, effective weight of the soil also plays a role. So in that is more moisture, it not gives the better weight of the soil. So in such cases, we are using this dewatering. So these are the major purposes for dewatering. And also they consolidated the soil layers. So whenever we are consolidated the soil layers also the one of the purpose for dewatering. Coming to this, we are going to almost we tried drain out the water. So that is the dewatering. Coming to this, the vertical drains can be classified into two types. Here the vertical drains we are going to classify into two types. The one is sand drains and the second one is prefabricated sand drains. Sand drains, prefabricated sand drains or wing drains. In coming to the sand drains, this sand drain system uses to reinforce good to poor soils, including soft to stiff clay and silt, loose to dense sand, organic silt. So like this sand drain system uses all these different soil conditions. In this, sand drains are used to reinforce and stiffen compressible foundation soils and increase the time rate of settlement by explosion of the pore water pressure. So in this, a circular casing or hollow steel mandrel of about 25 centimeters internal diameter and 6 meters height is driven vertically into a soft soil up to the required depth. So that is shown like this. So this is the sand drain. This is the sand. This is the sand drain. So like this we are going to understand the groundwater level. This is the groundwater level. This is completely sand. This is the groundwater level. And this is the sand drain. So a sand drain is a simple process employing a column of at least 10 inches. This is the space of 10 inches. At least 10 inches in width into the ground to be searched or consolidated. So the column in this filled with a sand and connected to free draining blanket of the granular soil. In this the surcharge and the sand blanket, these are the sand drains. Where it is required, we are going to consider this. So these are all the, somewhere it is the ground level is there, somewhere the ground level is there, the water is going to start ground level. And the remaining is, this is a remaining portion, it may be sand. After that ground level. So whenever the water table is ends, from there the sand is start. So these are all the sand drains. So like this, the sand blanket and the sand drain, the surge will appear. In this, the preload, whenever we are considering the water drainage, so we have to improve the ground. Whenever that is the soft ground, consider a soft ground. This is the overall soft ground we are consider. So in this, the preload, whenever the preload we are going to, it is there, and this is the water drainage which we create. So the movement of water is like this and this. So the excess pore water is coming from these ways. So these are all the vertical drains. So these are from the, whenever the excess water is there and the moisture content, we are going to reduce the ground level to improve the soft ground to hard ground, not that much completely, but the required effective weight of the soil. For achieving the effective weight of the soil, we are going to do this process. It depends from the how much the preload is there and how much we are going to, the excess pore water is going to the reduce using this drainage system. So this completely, these are all horizontal drainage, this is vertical drainage. So these are all the sand drains. So like that we are going to use this sand drives system for reducing the moisture content as well as for getting the effective soil weight. So the various different techniques for installation of the sand drives. So here we have the sand drives having different techniques for installation of their own. It depends upon the properties of the soil as well as which kind of water table is available and which type of soil is there and what kind of result we required. So these are all the three various characteristics which is depend upon which technique is suitable for installation of the sand drives. So before that we have to understand the three different techniques which are available in the installation of sand drives. The first one is mandrel drive and the second one is hollow stem, continuous plate auger, and the third one is the jetted hollow or closed end pipe. These are the three different installation techniques which we use for the sand drives. Coming to the first one, mandrel drive. In this method, the closed end pipe is driven to the bottom of the soil to be consolidated and it is filled with sand which is placed under approximately 100 lb per inch square of air pressure and then it is gradually lifted up out of the ground. So the closed end being a hinged value opens and the sand under pressure rushes out. So the pipe continues to be lifted until it reaches the ground surface. The entire process is then repeated for the next sand drain. So the complete cycle it took 2 to 10 minutes depending upon the local conditions. So it depends upon the local conditions like this. Whenever the closed end one is driven into the bottom of the soil, filled with the soil with some based on the required air pressure and given air pressure, gradually that is completely out of the ground. So coming to the closed end being a hinged value. So the open and the sand under pressure rushes out. Whatever it is going to be reduced, it will reaches the required effective soil weight or required how much water content is required for the construction that is left over in that particular location. The next one is hollow stem continuous flight auger. So here a continuous flight auger of the diameter as indented sand drains is rotated into the soil to the specified depth. It depends upon how much specific depth is there. For that, the continuous flight aggregator based on the diameter, it is indented and rotated into the soil. So in this auger is formed around a hollow pipe. Sand under pressure can be introduced into it and whenever that is again rotated out of the hole, whenever the sand drain is left behind and forms the sand drain. And this complete cycle time for the installation method is 5 to 20 minutes. It took the 5 to 20 minutes for completion of the cycle time. The next installation method is the jetted hollow or closed end pipe. In this, the driving into the soil of either hollow or either closed end hinged pipes via water jetting is also used for sand drive installation. This is also one more or closed. Already we see in previous installation method via water jetting is also used for this installation. That is nothing but the jetted hollow or closed end pipe. So previous we concluded for only the closed end pipe. Here we are going to increasing the water jetting. So the jet of water is nothing but the collection, how much of the pressure, the combination whenever it is comes out to that pipe, that is nothing but the water jetting. We are using that jetting to this hollow or closed end pipe. After pipe placement, the sand is introduced under pressure as the pipe withdraw. So the cycle time is 5 to 20 minutes. This is also same as the previous installation method. It's also took the 5 to 20 minutes. So coming to the process of construction of sand drive. So till now we understand the installation, what is the various different techniques which are used for the installation of the sand drains. Now coming to the process of construction of sand drains. In this, the driven casing is withdrawn after the sand has been filled. So a sand blanket is placed over the top of the sand drains to connect all the sand drains. Already we observe in the previous diagram how the sand drains to collect all the sand drains in the sand blanket. Already it is placed over, it is there, which is shown in this sand blanket, which is connected, or how many types of sand drives are there, which is connected like this. So this is nothing but the, which one is connected with all sand drains, that is nothing but the sand blanket. So to connect all the sand drains, to accelerate the drainage, a surcharge load is placed on the sand blanket. The surcharge is usually in the form of dumped soil. So the complete process of construction already we observed in previous one. So here that is the surcharge load. After that, the sand blanket, all the sand drains which are placed like this, which is shown in previous figure. So coming to the mechanism of the consolidation, the pore water pressure is increased by the applied surcharge load in the embankment. So, and the drainage occur in the vertical and horizontal directions. It depends. In some of the situations, the vertical and the horizontal dimensions, it depends upon the situation. So, whenever the water which we are collected and that was coming out of from the pumps, sometimes it may in vertical direction, sometimes it may in horizontal direction. So, the horizontal drainage occur because of the sand drains. So, all sand drains are like this. So, the horizontal drainage system which is occurred for the sand drains. So, the sand drains accelerated the process of dissipation of excess pore water created by the surcharge because of the load. How much excess which we are accelerated for these sand drains. So, based on these accelerated the process of and the various drainage different kind of horizontal and which type we are going to consider, and based on the water pressure, these are all mechanism of consolidation which we observed in sand drains. Coming to the spacing of the sand drains, it depends upon the various conditions. The drains are generally laid either in square pattern or a triangular pattern. Generally these two patterns which we observed in practical purpose. In practical cases, we observe all these two different types of patterns. The one is square and the other one is triangle. So, the typical design parameter of sand drain may vary in between these only. So, the spacing of sand drains 2 to 5 meters. Depth of the sand drains, it depends whether how much depth the foundation or how much depth the construction work is required. It depends. The drastic changes are there in this kind of depth of the sand. Remaining or not that much variation for the spacing of the sand drains except this depth. So it depends upon the which type of construction work we are doing and how much foundation depth or whatever the required elements which we are going to construct before the ground level. In addition to that, how much the water level is there. These are the two parameters are plays a role for taking this depth of the sand drains. For this depth it varies 3 to 35 meters. And the next one is radius of the sand drains well, that is between 0.2 to 0.3 meters. Thickness of the sand blanket also it is depends upon the 0.6 to 0.1. It varies which kind of construction and which type of soil it is, how much excess water is going to be evaporate in that and how much effective soil weight is required. So these are all the characteristics which we understand. Coming to the application of the sand drains, airport runways, it is very, very important because the runways are very in open places. So in that the water content, the water drainage system must be very good condition in airport runways. And next one is the golf courses, mine tailings consolidation, tailing ports, wetland development, building foundations, retaining walls, parking lots, landfills. These are the various kinds of applications which we use in these sand drains. So in this retaining walls, foundation, building foundation, whenever the water table is very near to the ground, so in that conditions, the foundation for the element of the foundation should be the strengthened. So it's not going to affect because of the water table. These kinds of drain off system is required. So for that we are using these kind of sand drains applications, that too the depth is in between 3 to 30 meters. So beyond that it is not going to apply. And next, coming to the retaining wall, also the same as for the building structure. Parking lots, so whenever the parking lots, so in that it's when the absorption of the water content is very important. Coming to the landfills also. So these are the some of the applications which we understand for the sand drains. So what are the advantages? So provision of sand drains allow drainaging of the pore water in radial direction in addition to the drainage in vertical direction. So with faster consolidation, already we observed the installation process took 5 to 20 minutes and 2 to 20 minutes like that only. So the faster consolidation also, it is having its faster consolidation, and the long-term stability of the structure is also increased because of the sand drains. Coming to the disadvantage, it requires frequent maintenance is required and time-taking process about an year based on the soil type, and sand drains may have discontinuities if the mandrel is withdrawn too fast. So these are all the some of the disadvantages which we are going to understand in these sand drains. So other kind of method we will see in our next class. These are the some of the web references for understanding the hydraulic modification, the two sand drains. It may helpful for us for understanding these modifications. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.